Hello friends, let's look at what exactly mean by data modifiers or qualifiers and why do we need these data modifiers or qualifiers. We have discussed what exactly constants are. When I write a number in C language which starts with a non-zero number, it will be called as a decimal integer constant. If it starts with 0, it will be octal, and if it starts with 0x, it will be called as hexadecimal constant. Now since our numbers which we are going to use in our programs and in our regular life is decimal integer constant, let's restrict our discussion to decimal integer constant. If I write a number, say 31792, this is a very much valid constant in C language because it starts with non-zero, it doesn't have any special character, sign may or may not be available, and since it is well within the limits of integer range, this will be called as a valid integer constant, and to be specific, it is called as valid decimal integer constant. Now, if I write one more number, let's put a number as say 35891. When I write a number of this sort, even though it might pass all the rules associated with integer constant, but still this is invalid number. Now why it is invalid? It starts with non-zero. Yes, it starts with non-zero. Does it have a sign? Yes, it has a sign, not visible, but definitely a number is positive by default. We don't have any special character. Yes, it doesn't have any special character, and the digits which I have used are from 0 to 9. All the 4 rules may be applied, but still it doesn't pass the last rule, that is range of the numbers. When the number is beyond the limits of integer range, we call that as invalid constant. Now the range which was specified for an integer constant is 32,768 on the negative side and 32,767 on the positive side. The number 35891 definitely crosses the positive limits of the integer value, hence it will be invalid, and the reason which I specify for invalid is out of integer range. So does it mean that C language has a restriction saying that you can use only a specific set of numbers? Can I use a large set of numbers? Can I use a very large number in which a scientific calculation is used? Definitely, when I do high-end programs with C language, the scientific numbers may be very, very large or very, very small, which might not fit within the integer limits. So in that case, I can make them as valid. So let's look at a reason why this is invalid. As I said, an integer constant is going to get 2 bytes of memory. That is 16 bits of memory, of which 1 is always given for sign. Now the numbers are stored in binary, hence 0 indicates that it is going to be a positive value and 1 indicates that it is going to be a negative value. So when I subtract 1 from this, I'll have space as 15 bits. So the total space which is available with us is 15 bits, hence the number which I'm going to use is minus 2 raised to 15 to 2 raised to 15 minus 1. Now why a even and an odd term? It is as per the rules of something called as 2's complement, which is actually a part of digital electronics, which we'll avoid discussing in this particular session. So the 2's complement rule restricts you with this particular range. Can I expand this particular range? Yes, definitely. We can expand this particular range by making this number to be stored in a larger memory space. Now let me rewrite the number 35891. Now when I associate a character L with this, look at this particular character L. The character L identifies that this is going to be called as a long integer constant. To be precise, it will be long decimal integer constant. What difference does it make when it is an integer constant and a long integer constant? When I say integer constant, this will get only 2 bytes of memory, whereas when I say long decimal integer constant, this is going to get 4 bytes of memory. So when I say 4 bytes, let's look at how exactly the memory gets expanded. Now let's assume that the memory space is 4 bytes, which means that it is going to be 32 bits. Now of which 1 bit is given for sign. So minus 1, I am left with how many bits? 31 bits. So the range which I can describe at this place is minus 2 raised to 31 to 2 raised to 31 minus 1. So definitely, when I say 2 raised to 31 to 2 raised to 31 minus 1 with negative and positive limits, 35891 is well within the limits of that particular number. So whenever we use numbers which are very large in magnitude, we can make these characters L appear ahead of the number, which will modify the data. Do we have only one modifier in C language? No, we have 3 different modifiers. Now look at those 3 different modifiers. The first data modifier is called as long, which is called as L, which is called as a long integer constant. The memory size for this is 4 bytes. As we have discussed, the range of the numbers is minus 2 raised to 31 to 2 raised to 31 minus 1. The second is going to be U. U stands for unsigned integer constant, which will have a memory as 2 bytes. Now question comes, an integer constant is also 2 bytes, whereas unsigned integer is also 2 bytes. What difference does it make when I put a character U ahead of the number? When I have a character U, it means that the number has to be purely a positive value. Probably you will not notice any difference with the memory size, but the range is going to be completely different. In this case, the range starts with 0 because the very first positive number is 0 and the entire 16 bits are allocated for the number. We have 2 bytes which is 16 bits and 1 bit which was supposed to be given for sign will now not be given. So I am left with only 16 bits of the number and all the 16 bits will be used with the number, hence the range goes as 2 raised to 16 minus 1. If you observe, integer has got minus 2 raised to 15 to 2 raised to 15 minus 1, whereas here 0 to 2 raised to 16 minus 1. The third and the last data modifier is UL, which stands for unsigned long. Even the range or the memory of this is also 4 bytes. How different it will be from L and UL? L is also 4 bytes, UL is also 4 bytes. As a character U is associated, this says that this is going to store purely positive values, hence the range will make a big difference. So 4 bytes is 32 bits. We are not going to give any single bit for sign. So all the 32 bits will be used for the number itself. So hence the range of the numbers starts with 0 and it ends up at 2 raised to 32 minus 1. So an integer constant is 2 bytes, unsigned is also 2 bytes. Long is 4 bytes, UL is also 4 bytes. But it is not just the memory size, it is the range of the numbers which makes a big difference with these characters. So the data modifiers or qualifiers are not going to modify the data, but they are going to modify the size in which it is stored. So in brief, if we have to summarize the entire stuff about the data modifiers or qualifiers, anything which is used to store a number in a very large data space rather than a compact data space, we call them as modifiers, data modifiers or qualifiers. L, U and UL are the 3 data modifiers used in C language. L stands for long, U stands for unsigned and UL stands for unsigned long. The memory size and the range has been discussed in length. Thank you.